Hello everybody and welcome to another video explaining the topics of mathematics. In this video I will be talking about simple interest and a few of the prerequisite ideas needed to understand how the simple interest formula works, such as decimals versus percentages, how to convert time to years. We need to know how to do that in order to be successful. I'll have one example of tax calculation in here because it does lead nicely over into the simple interest formula. And within this topic here, I will have some examples on how this works and how you solve for various variables in this formula. Let's get it. On this slide, I'll be going over the differences between decimals and percentages and how to convert between decimals and percentages. The first thing you want to know about this is that this all leads up to interest rates, right? We're talking about simple interest in this video. So interest rate is something that we are interested in, no pun intended. But interest rates are generally given as percents, and you'll notice that you'll know it's a percent because there will be a percent sign after it. But when you use that percentage in a mathematical setting, say a formula, you'll have to convert it to a decimal in order for the formula to make sense, in order for the percentage to make sense to math. But when you are solving, if you know all of the little bits of information and the question is asking, hey, what's the interest rate? Then you have to be able to convert a decimal, because that's what math will give you, and change it back into a percentage because that's what people understand. So again, you can tell the differences between percentages and decimals is that a percentage will have the actual percent sign after it, and decimals won't. Like all of these here are percentages and all of these here are decimals. So how do you convert from a percentage to a decimal? Well, all we have to do is take whatever number we have and divide it by 100. And whatever decimal we get after that is exactly all we need. So I can take this 5 here, I can take this 5 and divide it by 100, and that'll give me 0.05. And that's it. There is the decimal I need. The next one here, 43%, again, we can just take 43 and divide by 100, and that'll give us 0.43. 0.43. And I'm going to stop right here just for a second, because most of the time students have heard, oh, I just moved the decimal, I just moved the decimal, moved the decimal. That's fine, that's true, that's correct. So like for this particular example, 43%, the decimal comes after the whole number, so here it is. Dividing by 100 is the same as moving the decimal point 2 to the left. So it becomes 0.43, which is exactly what we got for our answer. Now if you try that little trick here with the 5, the decimal still comes after the whole number. When you move it to the right 2, we sort of have this empty space here, and if there's an empty space, you'll put a 0 in there. We can have as many zeros as we need to the front, so I could have written over here a 0 and another 0. There we go. And move the decimal point 2 places over, so it would have been 0.05, like you can see. So you can see pretty easily that this would be 1.57 as a decimal, and that this one would be 0.00014. I'm going to go ahead and just linger on this one for a few seconds. Go ahead, you can write this number down on paper in front of you, move the decimal point, fill in any zeros that you need to, and then you'll see that this will be the answer here. So here are all the decimal equivalents. And in these other 4 examples, really quick, we just have to change the decimal into it back into a percentage. So like right here, you'll notice we divided by 100. In fact, we divided all of these by 100 and got just a decimal equivalent here. For these, we would want to multiply by 100. So we're just going in the opposite order. So I want to multiply this by 100 and I would get 12, and that would be a percent. I could multiply this by 100 and I would get 216, and again, that would be a percent. Now, similarly to the changing a decimal to, changing a percent to a decimal over here, we moved the decimal point 2 to the left. Well, if we wanted to do the same thing over here, we would move it 2 to the right because we're essentially undoing what we just did. So I could move this decimal 2 to the right and say this would be 0.371%. Or I could move this one 2 to the right and this would be 98.765%. And just for one more, like if I throw a whole number out there, let's just say 7. Again, I know the decimal point is just to the right of the whole number, and I can move it 2 to the right. And we can put zeros after this now to get 700%. Another skill that you will need to be successful in computing simple interest examples or exercises is time to years conversions. So that means you can be given any sort of time unit like 45 days or 30 weeks or 150 months or 34 quarters and be able to convert it over to years. So in order to do that, what we should do is we should first figure out how many of each of these things are in a year. So here I have I'm looking for how many days per year, how many weeks per year, how many months, how many quarters per year, and here you go. So a lot of these are pretty standard, things you're used to seeing. Let's see, there are 4 quarters in a year, there are 12 months in a year, there are 52 weeks in a year, but this one, 360 days, that's clearly not true. But what ends up happening is with the number 360, a lot of numbers divide nicely by 360 or reduce with 360. So we will use 360 days to represent the number of years, a number of days in a year. All right, so on with the conversions. How many years is each of the following time lengths? So here you can see again, we have these different time lengths. We have 45 days, we have 30 weeks, we've got 150 months, and 34 quarters. So how do you figure out how many years is 45 days? Well, we just have to find the unit over here that uses days. So here it is, we've got 360, and we just have to divide 45 by 360 days per year. And really what we're mostly concentrating on are the numbers, the actual values here, 45 and 360. We want to reduce this fraction as quickly as we can. So you can see if any number divides evenly into 45 and 360. Let's say like, I don't know, 5 sounds good. So I can divide 45 by 5 and get 9, and I can divide 360 by 5 and get 72. The point in simplifying a fraction is to keep checking, does it simplify, does it simplify, does it simplify? So I look at 9 over 72, does that simplify? Well, yeah, at this point I understand that I could divide both of these, 9 and 72, either by 3, or if you can see it, you can divide them both by 9. So I'm going to divide them both by 9, and 9 divided by 9 in the top is 1, and 72 divided by 9 in the bottom is 8. So we get 1 over 8. 45 over 360 simplifies to 1 over 8. So what about all this other stuff? I've got days over years, or days over years. So what this ends up being with the units is it's always going to end up being a year, because that is what we're doing. We're trying to convert some amount of something that's not a year over into a number of years. And in this case, 45 days is 1/8 of a year. And we do something similar for all of these. So weeks, I would take 30 and divide it by 52 weeks per year. And again, our ending unit over here will just be year or years. 150 months. Well, how many months are there in a year? There are 12. So I would take this 150 and divide it by 12 months per year. How about quarters? I would take 34 quarters and divide by 4 quarters per year. And all you have to do then is know how to simplify the fraction. And if you can simplify the fraction, do it. And if you're asked for a decimal, then you can just put the fraction into a calculator and crunch out a decimal. Let me get some answers up here for you. So here are the answers for all of these. 30 divided by 52. The only number that I could see I could divide evenly into both 30 and 52 is 2. So I divided 30 by 2 and got 15. I divide 52 by 2 and get 26. So 30 weeks is 15/26 of 1 year. So very similar again here. 150 divided by 12. You can see that they would divide by 2, but then you would also then have to divide that fraction by 3. So I just went and did 6 right away because I saw it. You can divide 150 by 6 and get 25. You can divide 12 by 6 and get 2. And that is as simple as it gets. I cannot divide 25 and 2 by some other number that will reduce the fraction any further. So for this last one with the quarters, I looked at 34. I divided it by 4 quarters per year because that's how many quarters are in a year. And you'll notice that the only number you can divide into 34 and 4 evenly is 2. So divide 34 by 2 and get 17. Divide 4 by 2 to get 2. You'll end up with 17 over 2 years. Now let's say you're given something like this. So down here, 17 months. To find out how many years this is, you would have to divide by 12 months. Now I can tell you right now that you can try all you want, but there won't be a number other than 1, which isn't going to help. 1 will not help here. But there won't be a number that we can divide 17 and 12 by to reduce this fraction. So what we end up with here is a fraction that is irreducible. So we would just leave it as 17 over 12 years. All right, so tax calculation, one example. There could be a couple different ways that tax calculations get presented to you. One would be you're given a pre-tax amount, and what you would do is you would multiply the pre-tax amount by the tax rate. Here's this word rate. Guess what? It's going to be a percentage, which means we have to convert it to a decimal. To compute the sales tax. So I'm going to time out right there. We'll get to number 2 here in a second, but I want to stop right there. So what this means is that in order to find the tax charged on the $123.91 worth of merchandise I bought at the mall would be found by taking the $123.91 worth of stuff I bought and multiplying it by the tax rate, as long as the tax rate is a decimal. So in order for this to work in math, as I've been saying, we have to take the tax rate and change it into a decimal. So this would be 0.0825. So there's the decimal equivalent of 8.25%. And then all I would have to do is multiply this by the $123.91 of stuff that I bought to see that the total amount of money that I would be charged in tax would be the $10.22. Yeah, you have to round. And yes, if this number is 5 or greater, you have to round up to the next cent. That is exactly how governments work. That is how you are to calculate tax. If rounds up, government wants the money. All right, so it's 10.22 cents in tax. Now, that doesn't tell you what your total bill is. Your total bill, the overall amount of money that you have to pay, is the amount of stuff that you bought, like the value of the items you're buying, plus the $10.22 you were charged in tax. So the total amount here would be $134.13. So what's going on? Why am I showing you this? Why? It's just asking to find the tax. Well, it turns out that this formula, this little bit right here, really, really helps explain the simple interest formula coming up here shortly. So one thing I want to point out here is that the $10.22 here was computed by multiplying the original amount by the tax rate as a decimal. So what I'm going to do is I'm going to just take this blue box here and say that this blue box is equal to $10.22. I hope you guys can see that. This blue box equals this red box. So let me come back here and circle this in red. There we go. So these two things are equivalent, which means if I replace this red box, the $10.22, with the calculation I used to figure it out, it will still be equivalent to this expression. So let me write this in here like this. I'll have $123.91 plus, and in blue I'm going to write $123.91 times 0.0825. All right, so I did that. And yeah, this is still equal to $134.13 because I guarantee if you multiply this stuff out, you're going to get 10.22. You're going to add it to this, you're going to get $134.13. Great. That's not what I want here. What I want here is to take one more step. And this is where it gets weird because students lose sight of what a term is and what factors are and blah, 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 blah. You'll notice in this expression that I have now, I have two terms. Here's one term, here is another term. Each of these two terms has the value $123.91 in common. That means I can divide both terms by $123.91 and essentially do a reverse distribution. So here's what's going to happen. I'm going to reverse distribute, and this is what we call factoring. The math F word. We're going to factor the $123.91, and what that is telling us then is we're going to come over here and we're going to divide each term by $123.91. And you'll see that this will reduce, And this will reduce. Oh, that first term reduces all the way. Guess what you're left with? That's going to be a 1. Plus, when I reduce these away, I still have actually something left here. That's the 0.0825. So let me get that written over here, 0.0825. And that equals, you guessed it, the $134.13. So what's going on here? What do all of these numbers represent? This is vastly different looking from this. We're just adding two numbers together. Well, now we are adding two numbers together and multiplying by the original amount that we bought. And what's going on here? Well, to give this some meaning, this 1 here, right, if we distribute this back through, this 1 represents the total amount that we were purchasing, right? I purchased $123.91 worth of stuff from the mall. So that 1 would represent that initial amount. The 0.0825 represents how much tax was charged on that amount. So if we add our original amount in our tax, then we would get $134.13. All right, one last thing to come back here. It says to divide the after-tax amount by 1 plus the tax rate to find the pre-tax amount. So if I were just to look at this equation here, if I divide both sides by 1 plus 0.0825, it would cancel on the left side, and I would divide it by $134.13 by this expression, and it would give me the starting amount. Trust me, you can work it through yourself. I promise you'll get $123.91. You may have to round to get it, but it will work. All right. All of that on the last slide to be leading into this simple interest formula. Okay? So here it is. And you'll notice that there's a lot going on here with the last one. Simple interest formula, A equals P times, parentheses, 1 plus R times T, close parentheses. So here's this 1 again. So if you don't understand it from the last slide, maybe it will, seeing it a second time will be better. All right, so we have this. What are all of these letters telling us? Well, A is the accumulated amount, or we can say the future amount. P is what we would call the principal, or the amount right now, the present amount. T is time in years, so you would see why we would know how to convert different time lengths over into years. R is an annual interest rate as a decimal. So again, changing percents into decimals and back. Important ideas here. So, what is going on? What does all of this mean? Well, again, we can find our original amount. How much we're starting with right now is P. And you may notice that there is another formula down here. A equals P plus PRT. That we get by simply distributing P to 1 and P to RT. So what happens from there then is you can see we get this formula down here. A equals P plus PRT. Why is that important? Because the way money works, think about it. If you put an amount of money in the bank, and the bank gives you some interest payments along the way, as is what happens in the real world, that's what this PRT is. P is the interest. So we're adding some money to it, and in the future, you'll have a bigger amount of money. Hopefully, you'll have a bigger amount of money. So what this tells us then is that P times R times T is the amount of interest that you will earn over a certain amount of time. So the little formula for interest over here, capital I is for interest earned, is P times R times T. Okay, cool. So what's going on again? Well, we have some starting amount, we add some interest to it, and let's say time is 20 years. 20 years later, we have more money. Yay! So it is important to know that this P can be factored out of each term because you will be asked to solve for P. So you can use this equation or this equation, but I promise you this equation will most likely, almost always, be easier to use. This one I broke down like this just so I can explain how the interest portion is equal to PRT. All right, let's take a look at some examples on how to use the little interest formula first, and then we'll go over into using the full-fledged simple interest formula. Calculating things using the interest formula. So here you'll see we just have the short formula from the last slide, I equals PRT. So given 3 of the 4 values for this formula, you can solve for the unknown. So what I like to do, starting with example 1, you can see we're trying to find an interest rate. So if we're trying to find an interest rate and we know that I equals 14, the actual amount of interest earned was $14. The amount we started with was $609, and we had 5 months of the money sitting there. The first thing I like to do is just write down I equals P times RT. And then we'll fill in these numbers as we go. So I know I, pretty simple, I is $14. We know P is $609. R is unknown. And T. Oh, before I can put T in here, I have to remember that T has to be in years. So we have to come over here to the 5 months and divide by 12 and just see if this fraction simplifies. And unfortunately, this one won't. So we just have to put 5 over 12 in here. So this fraction is generally a bother for most people. So what we can do is we can multiply all the terms on each side. Now, mind you, there's only one term on the right side of this equation. A term starts with a plus or a minus sign, so there's a plus sign here. It's not written, but it is implied. And all of this is one term. So we only have to multiply the right side of this equation once by 12. It will reduce, leaving us with 12 times 14 on the left side is, what is that, 168. And what's left over here is we have 609 times R times 5. So we can multiply the numbers together. 609 times 5 is 3,045. And that's still being multiplied by R. Now, if we want to solve for R, it's a pretty simple solve at this point. Divide by 3,045. Divide by 3,045. That will reduce away to 1, and that tells us that the interest rate is 168 over 3,045. Now the problem here is that if you were going to buy a car or buy a house or sign up for a high interest savings account and someone came out and said, oh hey, your interest rate is 168 over 3,045, you'd look at them cross-eyed for a minute and probably walk away. So what we have to do is actually divide this out. So 168 divided by 3,045 gives you a decimal approximation of, let's say, decimal approximation 0.055. Let's go one more 1. But again, this is a decimal and not a percent. So you need to change this over into a percent, which would be 5.51% out to 2 decimal places. Again, I was able to figure that out by moving the decimal point 2 to the right. All right, next example. If we have these three values given to us, the interest rate, the actual amount of interest we earned, the interest rate, and the time in weeks, we can figure out what P is. So again here, I'm just going to start with writing down this formula, I equals PRT. I'm going to fill in what I know, which is 39 equals, P is P, I don't know what that is, but it's going to be multiplied by 0.03 because that's what the interest rate is as a decimal. And the weeks, we have to divide this by 52. So we can divide this by 52 and see if this fraction simplifies. And again, yes, it sure does. This simplifies. We can divide the numerator and denominator here by 4. So that'll give us 25 over 13 when you simplify those down. So the time here will be times 25 over 13. Now we ran into a fraction like back here in the last example. All we have to do to get rid of it is multiply both sides by 13. There we go. So 39 times 13 is 507. And on the right side of this, we can multiply the 0.03 and the 25 that are still there. And when you multiply those together, you get 0.75 P. And just like we had back here, right, we did that. We reduced the 12s, we multiplied this out, we multiplied what was left over inside the numbers that were left over. Once we were at this equation like this, we just divided by whatever number was multiplied to P. Okay, so we divide by 0.75. Oh, we're dividing by a fraction. That's okay. You'll have a calculator to figure out what that is. And that tells us that P should be $676. Cool, so this isn't so bad. It's not as bad as what you think. All right, last example. You let a payment lapse on a credit card. I did not mention it here, but we're only letting it lapse for a month. Also, never do that. Make sure you make your payments on time. But for this scenario, you let a payment lapse on a credit card for 1 month. How much interest will you pay on your, if your balance is $500 and your interest rate is 24%? So we know the time, 1 month. We know the balance, and that is P. So that's P here is 500. We know the interest rate. We're trying to compute how much interest. We don't know I. So when I write this formula down, I equals P times R times T. We know P is 500. We know R is 0.24 when you move that decimal 2 to the left. And I know that the amount of time is 1 month. We would have to divide that by 12 to get the number of years. So, I mean, that's it. Here we go. We can just plink all of this into a calculator and find that the amount of interest that would be charged is $10. And also a really big hit to your credit score. Don't ever let your credit card payments lapse. So for our last topic here, we will work on simple interest, and it mainly revolves around using this particular formula. A equals P times 1 plus RT. So, I mean, let's just jump right into it. How much money will you have after 3 quarters of a year if you invest $42,000 at 3.05% annual interest rate? So one thing I want to mention that I don't write down in all of these examples is that these interest rates are always going to be annual interest rates. That's why we also have to have time in the number of years. So that being said, I already see we have 3/4. So 3/4, we would have to divide that by 4 to figure out how many years that is. And it is 3/4 of a year. So we can't simplify that down anymore. What can we do here? How much money will you have after 3/4? So we're asking a future amount, a later amount. A later amount would be A. So we don't know A, which means P would be $42,000. So here's our P. This would be our T here now. And our rate, our interest rate, 3.05%, would look something like this. 1 plus, this would be 0.0305. There's the interest rate as a decimal. And then we have our time as a fraction, and this is going to get a lot very, very, very weird very quick. All right, so if you're doing this and you're trying to figure out an accumulated amount, a future amount, there's no solving to be done. So what's really nice about this is that you can simply substitute everything in and crunch it out on a calculator. And you should get A equals, the accumulated amount is $42,960.75. And you always want to go out to 2 decimal places when you're trying to find an A value or a P value, because we are talking about money. The furthest out it'll ever go in real life and not in terms of stock markets or anything is 2 decimal places. Okay. Example 2. Determine the present value for $92,000 after being invested at 2.2% annual interest rate for 25 years. This sounds kind of like a retirement problem. Pretty cool. All right, so we know that we are sitting at 25 years from now, we're going to have $92,000. How much money do we have now? So let's see here. This would be... A would be 92,000. All right. A would be 92,000. We don't know P. We do know this is 1 plus R is 0.122, right? That's this as a decimal, times 25 years. We don't even have to convert this one. That makes my heart so happy. We don't have to convert this one. It's 25 years. How do we solve for P? Well, the first thing I would do is simplify everything in here first. Simplify everything in there to be 4.05. Now, since it's convention that we write a number being multiplied to a variable in front, this would be 4.05 times P equals 92,000. And I guess all we have to do now is just divide by 4.05. That's how we would isolate P, 4.05. So this tells us that the initial amount that we invested would be $22,716.05 if you round correctly. All right, one more example on the next slide. Your cousin Vinny lent you $2,000 and is coming to collect. You pay her $2,800 after running from her for 9 months. What rate was she charging you? All we have to do here is set up the formula. We have A, some future amount. Right? This happened later than this amount. We have P, an initial amount or the present amount, or the earlier amount, that $2,000, 1 plus RT. So this is the simple interest formula. Let's plug in the numbers into the correct place. We have 2,800, we have 2,000, and here we have 1 plus, we don't know the rate, but we do know the time was 9 months. All right, let's figure that out over here real quick. 9 months, there are 12 months in a year, you can reduce that down to 3/4. So this will be the time, and I will substitute that in for t and then write the rate afterwards. So this will be 3/4, and this will be r parenthesis. Okay, so we can distribute the 2000 here, and the 2000, this will be 2800 equals 2000 times 1 is 2000. 2000 times 3/4 is 1500 times r, the interest rate. So what we can do now is we can solve for r here. Solving for r would look something like subtracting 2000 from both sides. So that means we would have minus 2000 minus, whoops, there we go, minus 2000. And that would give us 800 equals 1500 r. And then we can divide by 1500. Those reduce, and this leaves us with 8/15. But I've gone over this already. We cannot leave it as 8/15. We actually have to divide those two numbers to get 0.53333, and those go on forever. And if we wanted to change this into a decimal, I guess this is an approximation here, this would be 53.33% out to 2 decimal places. Cousin Vinny is charging you literal an arm and a leg. That is more than any credit card I've ever seen. That might be payday loan type interest rates right there. So keep straight with Cousin Vinny. Thanks for watching this video. I hope you understand simple interest and how interest works in a much better sense. Good luck.